smallest to largest, starting with clay being the smallest and then gravel being the largest. So we're going to come back to this time and time again. Another way to visualize what I just showed on the previous slide. I always like to begin with this image here because it shows the outcome of erosion. We can see where erosion eventually ends up. And so we're going to be focusing in on this video lecture on rivers. And so in this case, the Gulf of Mexico, that sediment that we see here, it's all been churned up by a hurricane that's come through here, which has allowed it to be visible for us. But what we have here is essentially sediment that's been carried from interior areas. And so over time, weathering and erosion has taken sediment from the interior, and everything eventually then is dumped into the ocean, dumped in this case the Gulf of Mexico. We can really see that, especially there along the shoreline. Especially there along the shoreline, you see those darker tans and browns. Is essentially, the simple way to think of it is that it's just land, rock, bits and pieces of stuff that has been carried by rivers various distances and has eventually left it here at the coastline. Fluvial processes is just a big fancy word for saying river-related or stream-related processes, and so fluvial processes. And so when we think about glaciers, as we'll talk about a little bit later on, by far the most powerful erosive force we have. However, the glaciers aren't advancing. We don't have glaciers over Indiana right now. So the primary agent for landscape or landform change, especially here in Indiana, is moving or flowing water. So flowing water has definitely much more erosive capabilities than moving air, i.e. wind. So we think of it as kind of the sculptor, the primary sculptor of landforms, and we'll see various images of this on the following slides. Stream erosion characteristics as water dislodges, dissolves, as we talked about beforehand with karst topography, or removes the surface material. Surface material could be bedrock, so limestone, or just a loose material above the bedrock, i.e. soil. And so key characteristic, we're going to compare rivers versus glaciers. And key characteristic is fluvial processes carve out V-shaped valleys. So we should expect to see a ton of V-shaped valleys throughout Indiana. And we do. Now these V-shaped valleys are not massive, but they still nonetheless, you can see these V-shaped valleys in various forms, and we'll see some in the following slides. Glaciers carve out U-shaped valleys, and so very distinctive, and we'll see this on the following slide. And so here we have on the left fluvial processes that carved out this V-shaped valley, whereas on the right, glacier processes, this in case an alpine glacier or a mountain glacier, carved out a U-shaped valley.